Chapter 2 Advanced RAG, right? In my previous session we talked about hello world, about RAG session, about production. Now we are moving beyond the demos into the hard readiness scale, injection, retrieval with precision and safety, right? I'm speaking to tech leads and code developer today. We are going to cover the three hard problem every production system face right now, right? So how to handle complex document, how to gradual your system against the hallucinations, and let's deep dive in RAG at the chapter 2, right? So now here we are going to talk basic RAG words with demos, advanced RAG work in production. So but scaling in introduce three specific headers, right? Data volume, index freshness, and cost latency, right? When I talk about data volumes, we are talking about millions of document, PDF, tables, image. We can't just run a script. You need to batch pipeline, right? So in index freshness, right? The stable vectors equal wrong answer, right? If your data change daily, your embedding must need to be changed. You need to input data, you need to automate change detection. Cost versus latency. Embedding every token is expensive, right? And you need to two-stage retrieval, right? Caching to keep the cost linear, not exponential. So if you ignore these, your POC might fail at scale level, right? So now, advanced injection, handling the full spectrum here. Real enterprise data is not just plain text, right? And you need to have PDF, you need to have HTML, you need to have tables, image, and code. For PDF and docx, right? PDF and docx, we aware that we are going to use docling from IBM, right? This docling is from IBM. It's a preserve layers to reading order for tables. It doesn't need to jump tags. Use pandas or LLM caption also we can use, right? And for the code, we use AST parser like a tree, and so on. For tables, pandas, image, and code, this is AST. And docling is from IBM's, which we talk. For chunking strategy, we are going to use peak size for fast but dump, right? Sentence we the best quality but heavier. For semantic, embedded plus cluster is best quality, and hierarchical parent child is the sweet spot for complex question answer. Don't let injection bottleneck your retrieval. Now let's talk about large document and index freshness, right? How do you handle books or Wikipedia without losing context, right? So use sliding window, sliding window, right? Sliding window can overlap, right? 10 to 20% overlap. Splitting sentence, better yet, use parent-child retrieval, right? Keeping it fresh. You can't re-ingest everything every night, right? So you need to keep fresh, so you need to change detection, parent-child summary. So in incremental change detection, selective re-embed, only embedded what change upset automatically. It's like databases typically, and version control is kind of metadata, right? So now let's talk about BM25 vector, right? So vector search is great, right? But terrible exact match. It's very, if you use search error code 5 to 3, vectors search might not able to get, right? So hybrid search is work in that case, right? Hybrid search is combined basically BM25 and vector search, semantic we can say. So BM25 is what is TF-IDF, or we can say exact keyword matching, fast, no GPU, or lexical order, vector 25. And vector semantic search, its concept is matching, great parsing, and is cosine similarity in their use, right? Reciprocal rank fusion RRF, this is very important. Reciprocal, so merge two ranks, sum of 1 divided by 1 plus k d rank high. So merge, then use reciprocal. It's a merge rank. It's without reading score normalization. It's a production ready default support Elasticsearch. Yeah, this is the formula, right? And two-stage retrieval, so which we call stage 1 and stage 2. And stage 1 we call recall, and it's a top 10 candidate. Let's talk about like top 10 candidates using NN or BM25 is key here. So within So we'll get this data within 15 milliseconds and use quantile HNS index for scale, and we can. And now the precision slower attacks. Now you got cross encoder or LLM based ranker each candidate against the query. Return top 5 to LLM. So first we retrieve 100 and after 100 we retrieve top 5. Okay, so now why this stage 2 is matter? Because speed versus quality, right? ANN is fast but approximate. Cross encoder is accurate but slow. Combine both, get great speed and quality. Context window budget. LLM has limited context. Spending 100 chunks waste of token. 5 precision chunk is better to answer. Delivery control MRRR, right? So MRR is re-ranking, remove the near duplicate result, ensure breadth of coverage and cost efficiency. That's why the two stage is very very important. Now let's talk about re-ranking strategy, right? So relevance re-rank like BB2, relevance re-rank by BB2, or coherence score quality chunks pair for pure accuracy. MMR is means maximal marginal uh, margin and relevance. This means MRR. Balance relevance with diversity, right? Uh, versus mm, yeah, I mean it's diversity. You don't need to 5 chunks saying them things. And then we have customer ranker. This is fine tune on your domain if you have data. So this is custom ranker we can use. It's very important. Here is a pattern, right? I use pattern flag embedding, and for BZV2, right? Flag embedding BZV2, flag embedding BZV2, this one use flag embedding BZV2, right? And this is a compute score sort return top 10 single. So this is compute score sort and rank. This is where this is just prototype code. Now let's talk about Guardrails, right? It's for safety and injection defense. This is so security is not optional nowadays. The AI come, we need secure data, right? So you need gradual before after the LLM, right? Input safety. Here is we are going to talk about input safety. Use sealed grammar. So this is for sealed grammar from Google, or we can say Llama guards and blocking harmful input before hit your pipeline, right? So LlamaGuard is also this. Llama is sorry is from Facebook and ShieldGemma is from Google's, right? Now for prompt injection defense, so here is four approach: instruction hierarchy, input scanning, output validation, sandbox retrieval. Now hallucination detection. Hallucination detection, there is a two approach. How do you know if LLM is lying, right? This is hallucinations, right? So use HHEM. So this is HHEM, which is called Hawk's hallucination evolution model, right? This from Vectara, so one outcome Vectara. Its cross encoder train score fetches consistency, and it retrieve and generate score faithfulness 0 to 1, or highest 1 is highest, and threshold check if the less than 2 flag it. Alternately use LLM judge. This is LLM judge right below. Async monitoring, but HHM is faster real-time check, never ship RAG system in meaningful rest. So this is where we need to use detection flow, user query, retrieval generates, score faithfulness, threshold check, route. So this is what we are going to talk. Now next part in this slide we are going hallucination correction, self-correction loops that fix bad answer before they reach to user, right? So this is very important. Detection is useless without correction. What do you do with failful nodes, right? So what there is three techniques we are going to use: retrieve and retry. Expand a query with synchronous fetch fresh chunks, regard regenerates, claim level repair. Decompose the answer into atomic claim, verify each one, replace with one. So basically this is like a loop. Abstain gracefully. If refrain is failed, say I don't have reliable info, log human review. Design principle, a system that say I don't know, more trustworthy than the fabric answer, right? So this is very important. Now RAG user experience UX pattern, right? So backend quality means nothing if UX is broken, right? Uh, we need very so query input, streaming response, source creator, source cityness, confidence indicator, feedback bottoms, right? So streaming stream token reduce precise latency, so the search X source while the retrieving is ketones citizens is always interface retrieve chunks of footprint. Let's use a confidence indicator, so the visual score based on HHEM faithfulness, yellow base for low confidence, feedback thumbs up and down. Yeah, so the tool like streamlit and gradio, vector answer, LangChain, llama index, these are the things we can use RAG for user experience. Now let's talk about RAG architecture, that full stack, right? So bringing all together, production level code here is ingest I say docling, batch, embedding, incremental, index, HNSW or NM25x, a BM25, and retrieve stage 1 to 100 and then apply, another index, re-rank, using MMR, generate LLM streaming, grounding, and guards, hallucinations, right? These are things we need to use. Now this is the code. I'm going to talk first. Code is advanced injection. Let's look into injection code. We are using docling right here, and convert PDF markdown while preventing layout. We has every document track change records, right? So if you see the code, docling we use document converter. So document converter is converter, load document path, and then for loops, document export markdown text swatch has written document hierarchical chunking. This is chunk size, and chunk overlap is 64 is parser. Now here we do embedded upserts with change detection, right? So change detection, sentence transform, import sentence transformer, Weaviate and haslib. So upsert, we did upserts. This is a hybrid search. This is basically first hybrid search we use BM25, right? A keyword vector search is semantics separately. We use them RPF. So we use RPF, right? So RPF, as I said before, I believe reciprocal rank fusion, right? And normalize the score without tuning the second stage. Retrieval fetch 100 candidates and hybrid, and then we pass to BGEV2. So that's what I said, right? BG200 record BGEV2 and get top 5. So we sort the score, return the only top 5. So if you see here, there is a fetch, there is re-ranker compute score, then the sort is happening here, right? Now let's talk about production ready code, right? So production full guard code is guard, retrieve, generate, verify. From transform import this one to feedback logging. Yeah. So thank you for watching. Please like and subscribe my channel.